pollution is dangerous. Asthma, lung cancer, and heart disease all carry associations with the pollution you breathe. And the more you breathe, the more damage is done. That's why the Environmental Protection Agency is working closely with state and local agencies to enforce the Clean Air Act, one of several laws to protect our air quality.
AirNow is a website that tells the public about air quality from day to day in a given area. And AirNow usually reports what's called an air quality index, or AQI.
It starts good, green, moderate, yellow, and then what's called unhealthy for sensitive groups, which is orange. And if you get really bad air days around here, we can get up into the unhealthy for everybody, and that is the code red category.
We have a really good air quality monitoring network. It provides a wealth of information, but it's not everywhere.
We know the pollution at our monitors, but we don't know what's in between it. We can make a guess, we have models to help, but we don't know.
In general, the public has a tendency to continue to think that all air pollution is local. It's the power plant down the road, or it's the cars that are driving up down the streets. And clearly they're a part of the problem. But our research shows that somewhere between a half to two-thirds of our problem comes from transported pollution that actually happened the day before that mixes down the next day.
So in 2015, fire got started in Saskatchewan, and the fire put off a very prodigious smoke plume. It really was just a kind of a toxic soup mix that you shouldn't breathe. So thankfully, we could see the smoke on satellite. We get about one image of that a day. Even though it was 3,000 kilometers away, it ended up getting into Maryland, and we ended up having 4 monitors go into AQI code red.
So the current issue with the satellites is that they do pass over just a few times a day, and we already know that air quality is changing hour by hour, minute by minute.
It's not only important to have a long time series of air pollution data, but it's also important to have the hourly variations of those pollutants.
Tempo will solve this problem by maintaining an orbit directly over the United States, Mexico, and Canada.
It all starts with the Smithsonian, SAO, and our principal investigator, Dr. Kelly Chance.
Tempo is a satellite mission that consists of a spectrometer using technology that we've been developing for more than 30 years to use the spectrum of light to measure air pollution. We have a sort of a motto that says, Tempo, it's about time. But it means that we measure North America hourly during the daylight hours at a spatial resolution a little larger than the mall in Washington, D.C.
Tempo will measure each pollutant that has the harshest impact on human health and agriculture. Ozone, nitrogen dioxide, sulfur dioxide, volatile organic compounds, and atmospheric aerosols.
Basically, we have a wide range of chemicals that we measure that let us figure out where the pollution is coming from, how it's being transported and transformed. That data then informs air quality products, hopefully in near real time, enough so that you could decide whether you can go out for a run today.
The interesting twist for Tempo is that we're not going to fly on a NASA satellite. We're going to go on a commercial satellite.
These are beasts the size of a city bus. So we're like the bike rack on the front of the city bus.
It works well for all the parties involved. We expect to get access to space for a much lower cost than if we had to build our own satellite, while the commercial company gets an additional source of revenue.
We will be pointing directly on North America, and I like to say from sea to shining sea, from East Coast to West Coast, and then from about the Yucatan Peninsula in Mexico up to the Alberta oil sands. That will enable us to stay at North America and be able to swath across the United States every hour. We are going to be getting many data points throughout the daylight.
I'm hoping that our forecast will be able to shrink down in the timing and then the size, so we won't have to warn large areas anymore. We can maybe even see where these specific plumes are going, and then we can tailor the forecast to that.
So Tempo is a fantastic team. We've worked really well, have a great chemistry. NASA's role is to do project management, system engineering, as well as integration and safety and mission assurance.
And then the instrument itself is being built at Ball Aerospace in Boulder, Colorado. It's a place that I particularly know well. I've worked with them in the past successfully on several instruments, so they were the obvious choice to make the instrument. Air quality is a terrible disease causer, and it's a terrible killer, and so knowing where it is and where it's going and knowing how to diminish it are very, very important.
When Tempo does launch, those teams are going to be pulled all together. Everyone's going to be so excited. I call it, is it a golf clap or is it a NASCAR clap? And it's more like NASCAR, and that's the way I'm going to be. It's going to be, ah!